Today we're going to talk about the brains of a modern control panel, which is a PLC. And the PLC stands for programmable logic controller. And originally, control panels were built with relays, kind of like this guy here. And you would stack these up and connect them together. And if you wanted to change the way a program worked, you rewired the relays. And that was called relay ladder logic. Okay? And so PLCs now are also called relay ladder logic because of the way that they're programmed. All right? So what a PLC does has made it very much easier to build a control panel, because you no longer actually need to know what the inputs and what the outputs are in a very specific way, like you did with relays. When you did a relay control panel, you had to figure out all of the circuitry and all of the logic as part of the electrical wiring diagram, and then your wiring was essentially your programming, the wires running from things. And what made it more difficult was that when you needed to control more than one device, you wound up ganging up multiple relays in order to get enough contacts to do that. So they came up with the idea of a programmable logic controller to simply replace relays. And originally that was what they were used for. They were just relay replacers. You could take a whole panel that had 100 relays and replace it with one PLC. Okay, and so why a PLC? Why not other controls? Well, there's a couple of big advantages to the PLC, and they keep talking about how the PLC is going to become obsolete and go away. Never going to happen. And the reason is it has too many advantages. One of the things is that PLCs generally are very simple devices, and as a consequence of that, they are also very, very reliable, to the point where I personally have PLCs out in the field still running every day that have been running for 25 years. Okay, and so they're not like a PC that's obsolete a week after you buy it. This PLCs have a very, very slow obsolescence. This particular one we're using here, I've been using for 8 years. I used a previous one that goes back 30 years, and I can still get parts for them. So PLCs are very different in that their whole reason for being is that they don't get changed out, they don't get replaced, and they just keep running. So there's no like boot up sequence, and they don't hit you with a message saying, oh, this is out of date, that's out of date, I can't work. So they're very robust, and originally as I said, they were just relay replacers. But what's come along is that they've started expanding what a PLC can do, and the PLCs are directly tied to the microprocessor industry. And one of the things is that they tend to have way less memory than a PC. Like this one only has about 1 megabyte of memory, 1 megabyte, right? But it can do a lot of things with just 1 megabyte, because it doesn't have to handle a lot of things that a PC handles. Like there's no disk operating system, and the operating system of the PLC is very, very much simpler, and it's doing a lot of things that you don't realize when you're programming it, but it's robust in that way. Now you also see the Arduinos that have come out, and those little processors and the Raspberry Pis and stuff, and you say, oh, I can do all that with a Raspberry Pi or an Arduino. Yes and no. The problem with the Arduinos and the Raspberry Pis are that they don't have any buffering of the real world when you hook things to them. Most of their inputs are 5 volt or 3.3 volts. And what you don't realize is that a simple switch, when you flip a switch, the switch contacts are not instantaneous. They sit there and they bounce. And they bounce for 4 or 5 milliseconds, maybe. So in the PLC, the operating system of the PLC buffers everything like that, and has time delays. So it says, I don't see an input unless it lasts 10 milliseconds, right? So the bounce went away. And that kind of stuff, if you're doing it in an Arduino or a Raspberry Pi, you're writing a whole bunch of code to make that happen. And this is one of the reasons that they tend to be squirrely when you build something and you say, well, it works most of the time. Yeah, and a lot of times when it doesn't work, it's because you walked across the carpet and you created a little bit of static electricity, and that interferes with them. So PLCs have these buffered inputs and outputs, and there's in PLCs like this one, the time delays are adjustable. I can tell them to be longer or shorter, and to handle the noise of the environment that I'm dealing with.